Hello class, today we're going to review order of operations again. This time we're going to add exponents, and we're also going to look at how we combine like terms. So your essential question: how do I apply order of operations when working with expressions? Your learning intention: I'm learning to apply the order of operations when I have exponents. Okay, if you look, you have 4 different warm-up questions. Pause the video and do the warm-up questions now. Well, I hope you tried to do those on your own. So let's look at the first one. We're adding and we're subtracting fractions. What do we have to have in order to be able to do that? Yes, we have to have like denominators. So yesterday we were able to only transform one of ours into equivalent fractions, and we had the same denominator. In these cases, we've got to transform both. So I'm looking at 2 and 3, the numbers 2 and 3. Okay, I know that 2 is not a factor of 3. In fact, both of those are prime numbers, which means the least common multiple will be 2 times 3, which gives me 6. Okay, now just like yesterday, 2 times what gives me 6? That's times 3. I multiplied by 3 there, so I've got to multiply by 3 up here, so I've got that 3 divided by 3, which is 1. 1 times 3 is 3. Okay, now we're looking at 2 over 3. What do I multiply 3 by to get 6? That's by 2. Once again, multiply the 2 by 2 because I need that 2 divided by 2, which is 1 there. 2 times 2 is 4, not 2. Okay, I've multiplied by 1. I've multiplied by 1. That's why it works. Okay, you add the numerators and you keep your denominator. 3 plus 4 is 7. 7 over 6 is the correct answer. Any questions? Okay, once again, I'm trying to figure out what can I have as my greatest common factor here. 7 is a prime number, so I'm going to take 7 times 4 and I get 28. So both of these will be over 28. 3 over 7 equals what over 28? What am I multiplying by? I'm multiplying by 4. 4 divided by 4 is 1. 3 times 4 is 12. 12 over 7. Oh, 12 over 28. Oh my goodness, I got the bottom number wrong. Minus 1 over 4 equals what over 28? In this case, I'm multiplying by 7. 1 times 7 is 7. Minus 7 over 28. 12 minus 7 is 5 over 28. 5 is prime, so I know I can't, and it does not divide evenly into 28, so I know I'm done. Okay, now the next one is a concept you might not be really familiar with. What does 3 raised to the second power mean? 3 raised to the second power means 3 times 3. 3 times 3 is 9. That 2 tells me I have 2 factors of 3. 5 raised to the third power tells me I have how many factors of 5? 3. 5 times 5 times 5. 5 times 5 is 25 times 5. Okay, change it into money. It makes it easier. I've got 5 quarters. How much money do I have? $1.25. None. Okay, so when we're looking at exponents and we're getting ready to work with them more, the exponents tells you the number of what of the base that you have. If you said factors of the base that you have, so this is your base raised to your exponent. So we're going to simplify using order of operations. Well, that's that PEMDAS. So if I am looking at the first, do I have any parentheses? Do I have any parentheses? No. How about exponents? Yes, there's my exponents. That is the first thing I need to do. Okay, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 to the third power is the number 8. Okay, I've done my exponent. After exponent, what comes next? Multiplication or division, whichever you see first. Well, we see the multiplication here and the division here. So we're going to do those next. 5 times 3 is 15, plus 8. Negative 35 divided by positive 7. Negative divided by a positive is negative. 35 divided by 7 is 5. Now, what do we do next? You add, and then you subtract. 15 plus 8 is 23 minus 5. 23 minus 5 is 18. How do I do it so quickly? Well, I look at this. 5 is 3 plus 5. So 23 minus 3. 5 is 3 plus 2. So 23 minus 3 is 20. 20 minus 2 more is 18. Okay. For the next one, what do we do first? P stands for parentheses. So we have to do what's in parentheses first. So this is 6 raised to the second power minus 2 raised to the second power plus 3 raised to the third power. Okay, now what do I do? I've done my parentheses. What comes next? Well, I've got 3 exponents and I can do them all at the same time. I don't have to do one at a time, one at a time, one at a time. 6 squared. 6 times 6 is 36. Minus 2 squared. 2 times 2 is 4. Plus 3 squared. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay, we've got 2 more steps. I will have to subtract first, and then I will add. 36 minus 4 is 32, plus 27 equals. Okay, so if I'm doing this, 2 plus 7 is 9. I don't have anything to carry. 3 plus 2 is 5, so it is 59. And we are done. So if you have any questions, back the video up and listen to it again. If you don't have any questions, go to the next page, please. Okay, on the next page, we have 3 things we need to define. The first one is like terms. What are like terms? Like terms are terms with the same variables raised to the same powers. Variable or variables, whichever, it might be more than one, raised to the same powers. So if I'm looking at this, some examples, I could have 2x squared y, and I could have negative x squared y. The coefficients are different, but the variable and its power are the same. Expressions are a mathematical phrase that contains numbers and/or variables combined with operations. Okay, my spelling leaves something to be desired today. Okay, so a mathematical phrase that uses variables and/or numbers combined with operations. Now remember, your operations are multiplying, dividing, adding, or subtracting. Those are your four operations. And your expressions do only have variables and numbers. So what is the difference between an expression and equations? Well, equations are also mathematical statements, but they also state that 2 quantities are equal. So for an equation, you have to have an equal sign. A mathematical statement that two expressions are equivalent. A mathematical statement that two expressions are equivalent. So if you look at everything that we're going to simplify, there's no equal signs. So these are all expressions. They are not equations. So the way we deal with the expressions, if they have the same base and the same exponent, all we deal with are the coefficients. The coefficients are the numbers in front of the variables. So if I'm looking at this one, -3 plus 6 are my coefficients, followed by the p. I'm using the distributive property in reverse. So -3 plus 6, well, 6 is bigger than 3. So I'm going to subtract. 6 minus 3 is 3. And I'll keep the positive sign because 6 is a bigger number. Okay, for the next one, I'm going to rearrange it with my variables, my terms with the variables first. So it will be b minus 2b. And then my numbers next. -3 plus 6. Looking at your coefficients, if I had to put a coefficient in front of b, what number would it be? Well, it would be 1. So this is 1 minus 2b. And then I've got -3 plus 6. I had that up here, so I don't need to redo it because I know the answer will be 3 plus 3. -1 minus 2 gives me -1, b plus 3. Do I need the 1? No. If we have -b plus 3, we understand that coefficient of b is -1. Any questions? Okay, so as we're looking at the next problem, my coefficients are -33 minus 49 followed by v. Okay, they're both negative numbers, so I'm going to add the numbers together and then keep that negative sign. 33 plus 49. 3 plus 9 is 12. Put down the 2, carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. This is -82v, and we're done. If they're the same sign, you add them together. If they're opposite signs, you find their difference and keep the symbol from the number that is the bigger number. Okay, for the next one, I want you to pause the video and think about what we will do first when we have parentheses. What do we do first? If you said combine what's in the parentheses, you would be right. But in this case, 7 minus n cannot be combined. So now we are going to multiply both terms that are inside the parentheses by what's on the outside. Negative 2 times positive 7. Negative times a positive is a negative. 2 times 7 is 14, so it's negative 14. Negative 2 times negative 1n. Negative 2 times negative 1 is positive. 2 times 1 is 2, followed by the n. Then you simply bring the plus 4 down because there's nothing that you need to do with that. Okay, I'm going to rearrange. I am going to get my numbers together. I'm putting it in what we call normal form. 2n minus 14 plus 4. Combine your numbers. They are opposite signs, so I subtract. 14 minus 4 is 10. Keep the symbol of the bigger one, so this is 2n minus 10. So remember that negative is going to be coming up here to the 10. That's where the negative 10 comes from. Okay, I want you to pause the video. Can you do the last one? Can you do the distributing on the last one? If it is not there, it's understood to be negative what? Negative 1. I can't combine inside, so once again, I've got to distribute. Okay, negative 4p, nothing to do with it. Negative 1 times positive 1. Negative 1 times positive 1 is negative 1. Negative 1 times negative 6p. Negative times negative is a positive. When I was growing up, okay, she told me to just change this to a positive, change everything in here to its opposite. And if you do that, you will once again get negative 1 plus 6p here. Okay, let's rearrange. We've got a negative 4p, we've got a positive 6p. Negative 4p plus 6p minus 1. They're opposite signs, so I will subtract. Okay, this is my bigger number, so I know that this will stay as a positive. So this is positive 2p minus 1, and we're done. So, how do you know when you're successful? Well, you know you're successful when you can apply the order of operations and combine your like terms. So order of operations we've already worked with. Simplifying expressions. And we're done.